Alright, it's time for another math. Easy solution to discuss. Factorials, a brief introduction to it. Basically, here's an example. You've probably seen this before. 5 exclamation mark or 5 factorials. 5 times 4 times 3 times 2 times 1. This is equals to 120. So basically, the general definition is defined for if you have, let's say, n is equal to positive integer. It's only defined for this. Like 5 here. So you can't have negative and whatnot. And can use fractions like 5.5, so just whole numbers, and then so it's defined like that. So and factorial, this was just equal to 1 times, well, 1 times 2 times 3 times etc. all the way until n. And it's also defined for 0 prime. This is equal to 1 and this is by definition, and this is based on the the empty product rule. Yeah, so this one I'd probably do another math easy video on this later time, explaining further. But basically, this just is a convention it's just a convention that says, it states that the product of no numbers is just 1. And in this case, 0 prime. This isn't. This is actually just no numbers times itself is 1. This is convention that's used. It's really useful in a lot of mathematics and stats and statistics and whatnot. So basically, so this is the definition. You could also write this in a recursive definition. So recursive definition, this basically reiterates itself. So you could write this all in one function. This could be equal to n prime is equal to, or n factorial is equal to, it's equal to 1 if n is 0, and it equals to n minus 1 factorial times n if n is greater than 0. So as you can see in this case, it just reiterates itself. So this is what it means by recursive. It keeps going back into its same function. So for example here, if you had 3 factorial, you're just going to get, so if you had 3 factorial, you're going to get, well, it's not equal to 0, so then this one would just be equal to, well, n minus 1, or n minus 1 is just 2. Yeah, 2 factorial times n, and 2 factorial will just be equal to 1 factorial times, well, this n is 3. Yeah, times 3, and then this one's going to be, well, this is 2 right here, so this is going to be the new n, so that's just going to be 2 times 3, and then this 1 factorial is just equal to 1. Yeah, so this is going to be 1, and then it's going to be 0 factorial. So you're going to equal to 0 factorial times 1 times 2 times 3, and this one is just 1. Because if it's 0, it's just 1. So then you're just left with 1 times 2 times 3. We have an extra 1, but that doesn't change anything. So this one's just 6. So you could do it, this one is used for if you have functions in your calculator or whatnot. But in Excel or whatever you're using it for. But basically, just do it like this. So now let's look at some examples. So yeah, the examples are pretty straightforward. If you have 4 factorial, this one is just equal to 4 times 3 times 2 times 1. This just equals 2. Well, this is 4 times 3 is 12, is 24. Now if you had something like, let's say 6 factorial divided by 2 factorial, this is another example. Well, this just equals to, this just equals to 6 times 5 times 4 times 3 times 2 times 1. And yeah, this is going to be, well, this 2 right here, so you just cancel these 2 right here, and you're left with, this one is 30 right here. 30 times, this was 12. And this actually just equals to 360. And from this one right here, we see that, well, this one just equals like that. So you could also do this really quickly. And if you had, let's say, 6 factorial divided by 4 factorial, we know that the top part just equals to 6 times 5 times 4 factorial. This one's 4 times 3 times 2 times 1 by 4 factorial. So we cancel out this entire thing here. This is equals to 30. And yeah, factorials come up a lot in mathematics and probability and combinatorics and whatnot. And its most basic use is right here. Basically, if you have n objects, n distinct objects, or distinct numbers, say distinct numbers, so there's only one of them, not like, yes, if you have 1, 2, 3, 4 and whatnot, then there is n times ways of sorting them in a sequence. Yeah, and to illustrate this, we'll just do an example right here. Let's say we have example the letters A, B, C, and D, and we want to know how many ways of sorting it. Okay, so basically from this statement that I made here, it should be n factorial, where in this case n is 4, and then we'll just have 4 factorial, which equals 4 times 3 times 2 times 1, and this just equals 2. Well, this is 12 times 2 is 24. So it should be 24 ways. But now let's, I'll just do a little quick proof of this, and then in my next video I'm going to do a proof of the general for if you have n objects. Basically, let's just start off with ordering all these. Let's start off with just write A, B, C, D. Okay, so now if we have A, B, C, D, this is one way of sorting it. We could also now, let's just shift we shift it incrementally by one to get different sort. Yeah, so we do this by shifting to the right, so then we will get, well, if we shift this to the right, where the B goes here, so B, C, D, B, A, C, D, then B, C, A, D, so the A is shifted one to the right every time. B, C, D, A. So now here we have four ways of sorting it. Now if we look at each separate one of here, let's just look at this one right here. So if we break this apart and seeing how many ways this can be sorted, well, this one we'll just write A, B, C, D. And now here we'll just fix A, so we'll make it stationary. And now we do the same thing as before, but with B. So now we shift to the right. So then we will get A's here, B, whoops, now this is a C, B, D. And now here we'll get A, C, D, B. So it's just a diagonal of B's across like that. And this one has 3. So what this is saying is that this first section, A, B, C, D, can be sorted 3 ways, in just A, B, C, D, A, C, B, D, and A, C, D, B. But now if we take this one here, we can do every single one. This one here we'll get, now we could shift, we'll fix A and B now, just to show you different ways of sorting this one. So now here, if we fix these two, so we'll just write fix them by just make them stationary, not changing, and now we shift to the right the C. So then we'll just get A, B, D, C. So there's a diagonal across there, and now this one has 2. And then we do the same thing for this last one. Well, A, B, C, D. Well, we fix these 3, and we shift D to the right, but it can't shift anymore, so this is all we're left with. And this one has 1. So and then if we do this for every single one, it's gonna be the same thing. Like if we do this one right here, this one just has 1, and this one here we could break this down into 2 as well. So you could do the same thing. This would just be A, C, B, D. We will fix. Now this time we'll fix A and this one we'll fix A and B as well here. This will be fixed. This will be the same thing as here, but now the B, A, B are different positions, and then we'll just shift this to the right. So we'll just get A, D, B, C, and this one has 2, and so on. You could do this. Now this one here, this will also be the same as above. So you'll have it. It'll be the same thing as above. We'll just fix B. We'll fix A, and then we'll just shift B as well. So this is all we're going to be doing. So then when you put this all together, well, I'll just do this one quickly here just to get an idea. It'll be a bit different. But remember, you always fix A regardless of where it is. And then the second one you always fix A and B, and then third you always fix A, B, C. So this one we'll get B, let's go B, A, C, D. We fix this, and then this one we shift right. So we'll get C, A, B, D, and then C, A, D, B. And this is 3. And so on. Then this one you'll get it break it down to 2, and this one just is just stationary 1. So when you put this all together, it shows that this here, like this one will do this 4 times. So we'll just start with the right. Actually, we'll just start with this full thing here. So what we could do right here is we could have 4 ways of sorting this of these ones, but each single one has 3 ways. So each single one, that's 12 ways right there. So we could have 4 times, well, which is comprised of 3. So 4 times 3, but this one's comprised of 2. So each one of these, this is 3 times 2, it's 6. So then what we could write it as is 3, this one's comprised of 2. And then the last one, each single one's comprised of 1. So 1. And close all the brackets. And this is just equals to 4 times 3 times 2 times 1. This just equals to 4 factorial, and this equals to 24. So there's a little quick proof of this one. But yeah, hopefully you wrap your head around this one. Because remember, this one is 4 ways of sorting ABCD. ABCD can be sorted 3 ways, so we have to multiply it. Every single one of these can be sorted 3 ways. And every single one of these can be sorted 2 ways. Every single one of these can be sorted 1, so we have to multiply it by how many different ways we could sort it. This one 2 times 1, and then 3 times 2 times 1, and this one is 4 times 3 times 2 times 1. And then you get here. But my next video I'm going to do this in a general n objects, and then it'll be the same thing here, but just with general n. That'll be my next video. Hopefully stay tuned to watch that. Well, that's all for today. Hopefully you learned about factorials, and learn this recursive definition is pretty useful. And also just keep in mind how you could easily divide factorials and whatnot. Well, that's all for today. Hopefully you learned, and stay tuned for another math.